Welcome to qnawire.
Let's have a look at intermolecular forces today. And for this problem, I feel like it is necessary to first define what a homogeneous mixture is. So, the word homogeneous is Latin for same kind. So that should give you an idea of what the definition would be. It is a substance that contains only one kind of compound or element. Another important property of homogeneous solutions are that it has uniform composition and properties to it. This is why the air is a perfect example of a homogeneous mixture because it has all the same compositions of gases such as nitrogen, oxygen, carbon dioxide, etc. So these are the four pairs of molecules that we have to look at and see if they can mix together to form a homogeneous solution. And of course, I encourage students to pause the video, do it themselves, and come back to see if they got it right or not. This is the only way you can know if you fully understand the topic or not. So let's start off with the first pair. What do you notice right off the bat? You should be able to easily identify that these two molecules in this first pair contain London dispersion forces. These are the dominant intermolecular forces present in these two molecules, and we should be able to recognize that if these molecules have London forces, that means that they are nonpolar. No dipoles, nothing like that. They're fully nonpolar. So if you remember, homogeneous solutions, they have one key component and one key concept that they follow. Like dissolves. Like. Since these two molecules are both nonpolar, they will be able to dissolve to combine and form a homogeneous solution. So for this one, yes, these two molecules can combine to form a homogeneous solution. Moving on to the next, CBr4, if you draw it out, bromine is more electronegative. So we can see that the bonds will form dipoles, but the dipoles will cancel out. So this whole molecule will be nonpolar. And then what about H2O? We have And we already know that water has hydrogen bonding because if you remember, hydrogen bonding is if a hydrogen bonds to a fluorine, oxygen, or nitrogen, and we can see that a hydrogen is bonded to oxygen. So this one has hydrogen bonding. So a nonpolar molecule with a molecule that has hydrogen bonding as its dominant force. So no, they don't combine. They can't combine together to form a homogeneous solution. Moving on to the next one, we know that water has hydrogen bonding, as we already talked about. Now let's look at Li. For Li3, lithium nitrate, where you should recognize immediately is that this is an ionic solid, so we cannot talk about intermolecular forces here. So ionic bonding is way stronger than hydrogen bonding, so they won't be able to combine together to form a homogeneous solution. Ionic bonds are way too strong to combine with hydrogen bonding. Moving on to the last pair, we can see that CH3OH has a hydroxyl group. So that means that there's hydrogen bonding present because a hydrogen is bonded to an oxygen. And then for this molecule here, it is London dispersion forces, so it's nonpolar. So hydrogen bonding is way too strong to combine with a nonpolar molecule that has London dispersion forces. So this one will be no. So the number one, the first pair, is the only one that can actually combine to form a homogeneous solution. This is because they're both nonpolar, they both have London dispersion forces, so they can combine.